Given a numeric string number that is already a palindrome. Rearrange its digits to form the smallest palindrome strictly larger than number. If no such palindrome exists, return the empty string. Example 1, input number is 1, 2, 2, 1. The answer is 2, 1, 1, 2, the smallest palindrome strictly larger than the input. Example 2, input number is 3, 2, 1, 2, 3. No rearrangement forms a palindrome strictly larger than the input, so the answer is the empty string. A palindrome is completely constrained by its own structural symmetry. The second half is nothing more than a perfect mirror reflection of the first half. This means we don't need to manipulate the entire string. Any change we make to find a larger number must happen entirely within the first half. Our goal is to find the smallest possible palindrome strictly greater than our original. Since the first half dictates the overall value, this task transforms into a classical subproblem. We simply need to find the very next lexicographical permutation of this first half. To find the next permutation, we scan backwards from the end of our half string to find our pivot point. We look for the first character that breaks our descending sequence, the first element that is strictly smaller than the neighbor immediately to its right. Here, our pivot is the number 1. Once the pivot is found, we scan from the right edge inward again. We are looking for the smallest element that is still strictly greater than our pivot number. Scanning back, we hit the number 2, making it our swap candidate. We swap our pivot and our candidate. Now, to make sure this new half string is the absolute smallest possible increment larger than our original, we take everything to the right of our pivot position and reverse it completely into ascending order. Our new optimized first half is ready. With our new first half locked down, mirror it across the center to rebuild the palindrome. When the length is even, there is no middle digit, copy 2134 to the right in reverse order. When the length is odd, keep the middle digit fixed and mirror the half on both sides. 1 2 on the left, 3 stays in the center, 2 1 on the right. With an odd length string, our extraction step requires precision. We isolate the first half of the string into our working array, but we deliberately lock the absolute middle element inside a fixed center anchor. This middle digit will remain completely untouched by our permutation loops. We scan our isolated half array from right to left to locate our pivot point. We search for the first element that drops in value compared to its right-hand neighbor. Moving backward, 4 is not smaller than 3, but 1 is smaller than 4, making index 0 our pivot. Next, we locate the successor candidate. We scan from the rightmost edge of our half array backward, searching for the first element strictly larger than our pivot value of 1. We find it at index 2 with the value 3. We swap our pivot element with our successor candidate. This increases the lexicographical value of our front half by the smallest possible increment at this structural position. To ensure this newly modified front half forms the absolute smallest sequence possible from this step forward, we take all elements to the right of our original pivot index and reverse them into ascending order. With our permutation complete, we stitch the full string back together. We copy our modified half into the front, drop the preserved middle 5 into the center slot, and mirror the front onto the back to finalize our next largest palindrome. N is the number of digits in number time is O of n, next permutation on the left half, then one mirror pass across the center. Space is O of n for the mutable digit list we rearrange in place. Function next palindrome takes the digit string number. Build a mutable digit list CS from the input. Store n and set half_n to n divided by 2. On odd lengths, the digit at half_n stays fixed as the center. Call the helper to advance the left half to the next permutation. If no larger permutation exists on the left half, return an empty string because no answer exists. Otherwise mirror the left half onto the right with a forward loop. Copy each left digit to its symmetric partner on the right. Join CS and return the next palindrome string. Function next permutation in place rearranges the prefix ending at index end. Start I at the second to last slot in that prefix. Walk I left while the sequence fails to decrease. Decrement I by 1 each step. If I fell below 0, the prefix is already the largest arrangement. Return false so the caller knows to give up. Set J to the last index in the prefix. Scan J backward for a digit strictly larger than ARR at I. Decrement J while the candidate is not greater. Exchange the pivot at I with that successor at J. Reverse the suffix after I so the tail is sorted ascending. Return true because we found the next lexicographic step.